So far, we've talked about the scientific method, unit conversion, significant figures, and even temperature. And I know what you're thinking. When do we get to start mixing things together? And we'll get to that. But today we're going to talk about what really matters. Matter. Before we can start to understand concepts like steel rusting and acid rain, we first have to understand what matter is and how it's organized. Matter is anything that occupies space and has mass. It exists in three states: solids, liquids, and gases. Solids are rigid. They also have a fixed volume and shape. Liquids, on the other hand, have a definite volume, but they don't have a specific shape, meaning they'll assume the shape of the container that they're in. Lastly, gases do not have a fixed volume or a fixed shape. They will also take on the shape of their container. Something that also sets gases apart from solids and liquids is their compressibility. It's relatively easy to decrease the volume of a gas, but there's very little compression in solids and liquids. Most of the matter around us consists of mixtures of pure substances. Wood, gasoline, soil, and air, for example, are all mixtures. There are two classifications of mixtures: homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures, also called solutions, have visibly indistinguishable parts and are the same throughout. For example, the air around you right now is a solution of a bunch of different gases, but you probably can't see the difference between them unless you have superpowers. Heterogeneous mixtures have visibly distinguishable parts. Iced tea, for example, is a heterogeneous mixture because you can visibly see the difference between the ice and the tea. Any mixture, whether homogeneous or heterogeneous, can be created and then separated by physical means into pure substances without changing the identities of the components. These are called physical changes. A good example of these would be boiling and freezing water. Boiling water doesn't change the chemical structure of the H2O molecules. You merely just change it from liquid to gas. Once separated, these pure substances can exist as either compounds, which are combinations of elements, or free elements by themselves. A compound is a substance with a constant composition that can be broken down into elements by chemical change. An example of this would be the electrolysis of water, where an electrical current is passed through water to break it down into its free elements, hydrogen and oxygen. This is a chemical change because we no longer have water, but free elements. Elements are substances that can't be decomposed down into simpler substances. They also have structure. They're composed of atoms, which have protons, neutrons, and electrons, but we'll get to that later.